Welcome to the MCAT Basics Podcast, brought to you by the physicians at Med School Coach. Each week, Sam Smith breaks down high-yield MCAT topics so you can score as high as possible on test day.
Hello and welcome to Prospective Doctors MCAT Basics with your host Sam Smith. The goal of this podcast is to cover the highest yield topics on the MCAT and provide you with some sort of insight into the questions that the MCAT really likes to ask. This podcast covers the Doppler Effect. I was looking back over the Hearing and Ears podcast that I did a while ago, and I kind of realized I never covered the Doppler Effect. This is quite a serious oversight on my part, as the Doppler Effect is something that has shown up on the MCAT and will continue to do so. So, with that said, this is a short podcast that covers the Doppler Effect. This material will show up on one of the 4 MCAT sections, the Chem Phys section. I hope you find this podcast helpful in your studies, and good luck to those of you who are taking the MCAT soon. Okay, so I'm going to go over a few different things here. I'll kind of first start with a conceptual definition and understanding of what the Doppler effect is. I'll give an example there, and then I'll talk a little bit about the mathematical definition of the Doppler effect, or I guess I'll kind of look at it from a mathematical perspective, and that I'll talk about the equation for the Doppler effect and kind of what that equation tells us and how we can use that equation. So the Doppler effect is a phenomena that's observed whenever a source of waves is moving with respect to an observer. And those waves can be of any different kind. They can be light waves, sound waves, even ocean waves. However, most of the examples that you'll see on the MCAT are in terms of sound waves. But just, throughout this whole discussion, keep in the back of your mind that this effect applies to all different types of waves. Okay, so here's what's really important to know. The Doppler effect causes sounds to be heard at a higher frequency or higher pitch as they approach an observer, and a lower frequency or a lower pitch as they move away from an observer. For instance, take the following example. Say you are standing on a street corner as you're kind of making your way towards the hospital because you're a badass, you're a cardiothoracic surgeon resident, and you're making your way towards the hospital when you see an ambulance approaching. And in this example, you are the observer, and the ambulance is the source of sound waves. Now, inside that ambulance is a patient experiencing a myocardial infarction, and they're on their way to the emergency room. And actually, you're going to see that patient later because you're performing surgery on that patient. And of course, none of that matters. I'm just trying to really put you in the scene. So again, imagine you are in this scene right now. And in terms of the Doppler effect, you are the observer, and the ambulance that's moving towards you is the source of sound waves. Now, as this ambulance approaches you, what you notice is that the sound coming from it is a little bit higher in frequency or higher in pitch. Then as it passes you, the frequency of that sound or the pitch of that sound drops. It sounds a little bit like this. What you heard is the sound of the ambulance being a bit higher pitched as it approached you, and then dropping after it passed you. Now, it's not like the sound is actually changing, right? The ambulance itself is making a constant noise. It's only the observed pitch or observed frequency that's changing. And this all has to do with the motion of the ambulance and what that does to the sound waves that it's emitting. I'll start with this question. What's the speed of sound in air? It is 1,100 feet per second, or 761 miles per hour, which, by the way, is as fast as some jets can fly. Hence, you've heard of jets breaking the sound barrier. That's because they're going faster than 761 miles per hour, or about that. Now, imagine that sound waves are propagating in all directions from the ambulance, almost like when you drop a stone into a pond and the waves there just radiate outwards. Now, with that in mind, let's take a look at the speed of the sound waves coming from the front and the back of the ambulance, assuming that the ambulance is driving forwards towards you. The speed of the sound waves at the front of the ambulance, or I guess propagating out in front of the ambulance, are going the speed of the ambulance plus the speed of sound. These waves are basically getting a boost from the ambulance because they're traveling in the same direction that the ambulance is traveling. So let's say that the ambulance is traveling 60 miles per hour, and we know the speed of sound is 761-ish miles per hour. That means that the sound waves that are propagating out of the front of the ambulance are going about 820 miles per hour. On the flippity, the speed of the sound waves behind the ambulance are going the speed of sound minus the speed of the ambulance, which comes out to be about 700 miles per hour. Now, that's a huge difference, right? The sound waves that are propagating out the front of the ambulance, or I guess in the direction of the front of the ambulance, are going 820 miles per hour, and the sound waves that are propagating out the back of the ambulance are going about 700 miles per hour. At this point, you might be like, okay, but how do wave speed and wave frequency relate? In other words, how is the speed of these waves related to the pitch or the frequency that I hear them at? And this is where I want to go back to thinking about the sound waves propagating from the ambulance like waves in a pond. So sound frequency is equal to the number of sound waves that pass through a point during a period of time. In other words, if I was a little bobber, like a little fishing bobber, the ones that are multicolored, little spheres that float in a pond when you're fishing, if I was one of those, and we're talking about the waves in a proverbial pond being like sound waves, then this is how many waves from that pebble pass through and make me bob up and down per time. So like per second, per minute, whatever unit of time you want to use. So the faster sound waves are traveling, the more they're going to go through a single point in space, and therefore the greater frequency that they're going to have. So that's all to say that sound wave frequency and wave speed are directly proportional. So when the ambulance is approaching you, the speed of the sound waves coming towards you is greater than when the ambulance is going away from you. Thus, the frequency that you hear as it approaches is greater, like this, than after it passes you when it sounds like this. So before I discuss the Doppler effect equation, let me reiterate. The reason that the sound waves emanating from some object that is traveling towards you sound higher in pitch than the sound waves emanating from it once it passes you is because these sound waves are moving faster when that object is in front of you coming towards you than they are once that object passes you, and now they're coming essentially out of the back of the object towards you.
At Med School Coach, we know that getting into medical school is hard. In fact, 60% of pre-meds who apply to medical school don't even get accepted. And if you want to get accepted into a top medical school, it's even harder. It's a complicated process, and even students with great grades and MCAT scores get left out. That's why more students than ever are turning to Med School Coach for admissions advising. Our advisors are all physicians and former admissions committee members, so they know exactly what medical schools are looking for. One-on-one admissions advising from Med School Coach makes all the difference. Our expert team will help you develop a game plan, prepare your application, edit your essays, and coach you for interviews. Every pre-med has a story, and we'll help you tell it so you can stand out from the crowd. Visit us online at medschoolcoach.com and use offer code PODCAST10 to save 10% up to $400 on a Med School Coach admissions advising package. You can achieve your medical school dreams, and Med School Coach can help.
The next thing I want to talk about is the Doppler effect equation. The Doppler effect equation says that the frequency of observed sound is equal to the velocity of sound plus the velocity of the observer divided by the velocity of sound plus the velocity of the source, all of that times the actual frequency of sound waves coming from the source. And for a situation in which the observer is standing still, like you on the corner as you're making your way to the hospital, that equation simplifies to the observed frequency is equal to the velocity of sound divided by the velocity of sound plus the velocity of the source, all times the frequency coming from the source. Now, with that said, you can memorize this equation, definitely add it to your Anki deck I think that'd probably be a good thing. But I think what's more important to know, obviously, for the MCAT is what this equation tells us. So there's two things I want to point out here. The first being a proportionality. So this equation tells us that the observed frequency is proportional to the speed of sound divided by the speed of sound plus the speed of the source. So for example, if we wanted to determine the frequency of sound coming from the ambulance when it's coming towards us, that would be equal to the velocity of sound divided by the velocity of sound plus the velocity of the ambulance times the frequency of sound coming from the ambulance. I think it's a pretty simple proportionality and definitely something worth remembering. Okay, so the second thing that I want to point out here is something that this equation doesn't tell us. And that's what it lacks completely, which is wavelength, right? This equation says nothing about wavelength. But in a way, it kind of does, though, because frequency and wavelength are very interconnected. For instance, there's an equation that says that the velocity of a sound wave is equal to the frequency of that wave times the wavelength of that wave. So as I've already discussed, frequency has to go up when the velocity of that wave goes up. Therefore, we know that wavelength must go down. So basically, when the ambulance is traveling towards you on the corner, the wavelength that you're observing is less than the actual wavelength that is being emitted from that ambulance. And once that ambulance passes you, the wavelength that you observe is greater than the real wavelength that that ambulance is emitting. And again, this has to do with the fact that the ambulance is moving, and that's changing wave speed. And I'll say too that we don't really observe wavelength, right? We more observe frequency since that directly correlates to sound pitch. But if you wanted to think about observing the wavelength of a wave, you can do that. Just remember the equation velocity is equal to frequency times wavelength. Wavelength and wave frequency are inversely related. You know, I could see the MCAT being a little bit tricky and asking about wavelength in a Doppler-like situation. So in that case, you'd have to use this equation that I presented, the Doppler equation, solve for the observed frequency of the wave, and then plug that into the velocities equal to frequency times wavelength to then solve for the wavelength of the observed sound waves. So that's it for this mini episode on the Doppler effect. I hope that you found it helpful, and I'm sorry to those of you who maybe listened to the Hearing and Ears podcast and were like, whoa, what the hell? Why did you not talk about the Doppler effect? I did now. So again, I hope it helps. If you like what we do, please go leave us a review on iTunes. It helps us in the rankings, and it helps us reach more students. See you next time.
Each episode of MCAT Basics is brought to you by Med School Coach. To access Med School Coach services, including MCAT tutoring and medical school admissions advising, visit our website at medschoolcoach.com. Good luck as you prepare for the MCAT, and we hope you tune in again next time.